So let's talk about compound interest. So here we're going to work on an application of the exponential function. So there are two types of compound interest that we have to talk about. But in this video, we're just going to talk about compound interest using this formula. So we have A of t is equal to some p times 1 plus r over n to the power nt. So that's the compound interest formula we're going to be talking about in this video. There's another type of compound interest, so maybe in the future we will talk about this one, where you have a of t is equal to p times e to the rt. Now this formula, we use it when we talk about interest that is compounded continuously. So this would be considered continuous compounded interest. And this one that we're going to talk about today, it's just talking about interest that is compounded either monthly, weekly, daily, once a year, twice a year, and so forth. So not continuous. And let's identify what these variables represent. So here we have a of t. Well, pretty much a of t is like your future amount. So you can say this is some future amount. So if you invest some amount for a certain period of time, what will be your a of t? So something like that. And then p of t is your present amount. How much are you going to put into investment? So let's call that initial amount or present amount, whatever you want to use to make you remember what P represent. And then R, it's going to be the rate. At what rate are you going to invest? And then N is representing how many times are we investing this amount per year. So N is the number of times an interest is invested. So that's N, and then T, of course, represents time. All right, so knowing these variables, now let's take a look at what could be a scenario that we can use this formula. So here's an example I have for you, and let's see if we can set this up, and then you can use your calculator to verify the answers, or at least get to the decimal expansion of it. So suppose a sum of 1,000 is invested at an interest rate of 12% per year. Find the amount in the account after 3 years if the interest is compounded in certain ways. So annually means when n is equal to 1, meaning we're investing it only once a year. And then semi-annually means that we're going to invest it twice. So this would mean n is 2. Quarterly means n is 4. And think of it, you have 4 quarters to make $1. And then monthly would be n equals 12 because there are 12 months in a year. And daily, that would be n equals 365. Okay, so knowing these n values, let's set up the first one for n equals 1. How much will be the amount after 3 years? So let's also label what we're given. So we're given the following in the problem. We're investing 1,000, so that's our P at an interest rate of 12%, so that's our R, and we need to find the amount, meaning A, after 3 years, so A of 3. That's what we're looking for because T is equal to 3. So given everything, we're going to set up the scenario for different types of investments. So for annually, we're going to have the amount after 3 years. It's going to be your initial amount, which is 1,000 times 1 plus R, 12%. Now make sure you convert percent to a decimal when you're plugging into a formula. So 12% can be converted to a decimal as 0.12. So you just divide by 100. That will be 0.12 over n, which is 1. to the power nt, so 1 times 3. That will be the amount if we invested just once a year. So let's check out what this is. So we have 1,000, 1 plus, well, plus 0.12, that would just be 1.12 to the power 3. So if I use a calculator, 1.12 to the power 3, I would get the answer, but whatever that number is, that will be the amount. Okay, so feel free to write that out. But pretty much the setup is done. Now, what about the second part? Semi-annually. What if we invest the same amount with the same rate for 3 years? So for that would be n equals 2. A of 3 is going to be 1,000. 1 plus the rate 12. Now here n is going to be 2 because we're investing a semi-annually to the power 2 times 3. And that would give us 1,000 plus, well, times. So we're doing 0.12 divided by 2. That will be 0.06. We add 1 to it. That's 1.06 to the power 6. And then again, feel free to plug this into your calculator and you get the amount after 3 years if you invested twice a year. Now let's do quarterly. We're going to choose n to be 4. So the amount after 3 years is going to be 1,000 times 1 plus 1.12 over 4 to the power 2 times, sorry, not 2, 4, that's our n value, times 3. So let's see what this will give us. So we have 0.12 divided by 4. Well, that's about 0.3 plus 1. So we have 1,000, 1.03 to the power 12. So that will be our setup for if we invested quarterly. And then monthly, we're going to have n is equal to 12. So the amount after 3 years, it's going to be 1,000, 1 plus 0.12 over 12 months divided by 12 times 3. So we have 0.12 divided by 12. That's about 0.1. And then plus 1 to it. So we have 1,000 times 0.01 to the power 36, because 12 times 3. And that will be the amount after 3 years if we invested using n equals 12. And what about daily? Or if you invest the same thing every day? So n is going to be 365. So we have, for n is equal to 365, we have the amount after 3 years is 1,000 times 1 plus 0.12 over 365 over 365 times 3. And yes, that's probably a huge number. So again, you probably need to use a calculator for this. So if I do 0.12 divided by 365, I get a very tiny decimal. So I have 1,000 times 1.0003. Let's just say 33 to the power. So again, 365 times 3, that would be 1,095. It's a pretty big number. So you can see if you actually take this further and put all of these numbers in a calculator, you'll see that if you invest it every day, it will be much greater than having it invested once a year or twice a year or 4 times a year or 12 times a year. So you can see it as you plug these numbers into the calculator. But hopefully the idea makes sense, and hopefully you know how to use the formula. Once you identify what your P, R, and T is, and then knowing how you're compounding it, plugging into the formula should become straightforward. Okay, all right, so that's it for this video.